In the previous videos, we mentioned about the design software for reinforced concrete structures. In order to model and analyze a structure, there will be inputs, processing algorithm, and also the design output. Every single stage needs to be ensured to be properly done, especially at the input part, which based on the output, there will be verifications required. You need to look into every single aspect from the material properties, type of materials used, the design codes, as well as some other settings in terms how the output of the analysis and design should look like. There are a lot of functions and features in the design software. You need to be first familiar with those features, look into every single aspect of it, make sure you comprehend them before you can proceed with the analysis and design. As designing reinforced concrete structures is a serious matter, it is not simply modeling the structures and then expect the software to do everything for you. There should also be your contributions in terms of the technical aspects, as you are the person who do the design. The software will only act as a tool for you to speed up your analysis and design process, as well as to increase the reliability of the result. Especially it eliminates the errors in terms of the calculations. However, if your assumptions or the properties that you use is incorrect, automatically the result will be incorrect as well. Therefore, you need to control at the input stage. Make sure you model everything is right. We also mentioned that there will be a numberless trial and errors, which you need to model the structures part by part to first ensure the integrity of the structures. You may require the functions of 3D view for you to actually imagine how the building should look like in the realities. This can help you to make right decisions in terms of the design and analysis. Next, based on the design outcome, you need to observe the analysis results as well as the design brief for you to do proper verifications whether you have done the modeling right. This is very important, as even though you have results from the software, there is no guarantee that the model result is correct. You will still need to do proper verifications to check the design outcome. Some software is quite powerful enough that after the design part, it helps you to produce the detailings. Again, you cannot fully rely on the detailing produced by the software. As in the previous videos, we mentioned about the software normally make it flexible, that it can be adopted in various conditions for various kind of structures of various dimensions. That means most likely you're going to model the essential part of the structure, where those minor details which represent the uniqueness of the structure as identified by the architect may not be able to be fully modeled. In this case, there will be a need for the post-processing as well as the final check. Another reason for this is the software helps you to produce the detailings. That drafts are produced which may not be properly organized. It may not be fully presentable to be as user-friendly as possible. At least it saves you a lot of hassle to produce the detailings line by yourself. Probably you cannot imagine how it should look like. Let us look at some examples. These are the beam sections as extracted from the software. It helps you to draw out every single element, but not properly arranged. If you zoom in the elements, there could be some notes given by the software notifying you certain things that you need to pay attention of. In fact, this software is powerful enough already to produce really good drawing in terms of the detailings. However, for friendly usage, you might need to simplify further, remove certain unnecessary lines or informations which may not seem to be as essential to the contractor, especially when you talk about the detailings of the beam. You are more concerned with the reinforcement bar. How many reinforcement bar required? Where should it be located? Where are the lapping length? And etc. There will be some needs for you to do some post-processing, deleting unnecessary or non-essential informations so that your drawing looks neat. Probably clearly indicate what are the reinforcement bar here. In fact, it is being given, only that is given in the other section, where the reinforcement bar is continuous. Automatically you expect this size and numbers of rebar will apply to the next span. This you need to consider the mechanism of site inspections, where the site engineers or the consultant will need to check element by element. It will be good if you have all this clearly provided. Sometimes there are some notes here indicate to you the possibility of the reinforcement bar exceeding the maximum allowable span, which is 12 meters. It is likely for you to have lapping of the reinforcement bar somewhere along the member. And sometimes you see overlaying of the text, which you need to do some modifications. This is another example. What you see here, there are 3 cut sections here, which in fact is not necessary. Even though you do these 3 cut sections, they are actually the same shape in the cross section. You can remove the redundancy in order to keep your drawing neat and tidy. There are a lot of overlaying text which you need to remove it so that there are no ambiguity with the drawings or unclear text. Same goes to this and this. This is another example, which is the clip length generated by the software, which at the end of the day it seems to be quite messy. You have so many lines overlaying each other. It makes the drawings to be quite difficult to read. And all the lines here are in the same color. It shows no classifications as well as the contrast among different types of the line. There is a need for this post-processing. And also we see the software generates a full list of the columns. Every single columns have different design, and each design here is applicable for one type of the reinforcement bar. This is very hard for the site personnel to manage. That means there will be post-processing for you to group the columns together so that you have limited numbers of the columns design to be applied throughout the structure. The same principles applies to the foundations. Normally we will prefer certain standardized size for easy management in terms of the construction process. I guess so far we have demonstrated to you the needs of post-processing based on the detailings as generated by the software. I would say that nowadays the software is already quite advanced. It saves you a lot of work. However, there are still limitations. It cannot be done fully to your expectations that everything's are fully automated. Even it could be done to be fully automated. This could also be quite risky for you. That removes your motivations to go further into the details for the final check. You know that the devil is in the details. Something might seem to be simple at the first look, but if you really look into the details, it can be a big deal. All this you need to take into the considerations.